All right, hello and welcome. Today, we are going to crack open question 1 from the AQA GCSE Higher Tier Physics paper, the one from June 2024. Our mission is pretty simple. We're going to break this question down, piece by piece, so you can see exactly where every single mark is hiding, and more importantly, how you can grab it. You ready? Let's dive in. For this deep dive, we're not messing around. We're going straight to the source. We've got the official AQA question paper right here, and the most important part, the final mark scheme. So this isn't guesswork, or my opinion, this is the real deal. We're looking at the exact documents the examiners use to grade your answers. So here's our game plan. First, we'll unpack what question 1 is all about. Then we'll tackle each little bit, one by one. We'll start with precision, then hit that big 6 marker on the experiment itself, move on to handling data, and then finish up with some core physics on light. And at the very end, we'll wrap it all up with the key things you absolutely need to remember. Okay, so question 1. It's all about a classic physics practical, one you've probably done in class, investigating how light refracts or bends when it goes through a glass block. This is actually a required practical, which means it's a perfect way for them to test your hands-on skills and see if you can think like a real scientist. Let's see what they're looking for. Right then, time to put on our examiner's hat and get into the nitty-gritty. First up, question 1.1. And we're starting with a really fundamental skill for any scientist, being able to read your equipment properly. It sounds simple, but you'd be surprised. The exam paper kicks things off with this picture of the protractor that the student used in the experiment, and the very first question is just a simple observation about this piece of gear. So, the question is, what is the resolution of the protractor? Now remember, resolution is just a fancy way of saying, what's the smallest change this instrument can actually measure? Have a good look at that protractor. What do you reckon? And the answer, straight from the mark scheme, is simply 1 degree. If you look closely, you'll see the smallest markings on there are for every single degree. It's a really simple point, but the mark scheme is incredibly strict on this. The only thing that gets you the mark is the number 1. No wiggle room. Okay, let's move on. And here it is, the big one. The dreaded 6 marker. Question 1.2 isn't just testing what you know, it's testing how well you can explain a scientific method in a clear, logical way. This is a huge part of the exam. The question asks for a method the student could have used to get their results. This is where you have to put your scientist hat back on. The goal is to describe a set of instructions so clearly that another person could follow them and get the exact same valid results. In science, that's everything. It's called repeatability. Now, this is really important to understand. Examiners don't mark these questions by just giving you a point for every correct thing you say. Nope. They use what's called a level of response system. To get into level 3, that's the top tier for 5 or 6 marks. Your method has to be logical, and it has to actually work. See? You can't just list a few random steps. If your method is all jumbled up, you'll be stuck down in level 1 or 2, no matter how many correct facts you throw in. So how do you build a top-level answer? The mark scheme gives us what it calls indicative content. Think of it like a recipe. You start by putting the glass block on paper and drawing around it. Then you shine a light ray through it. You mark where the ray goes in and where it comes out. You connect the dots. And then, this is the crucial bit, you draw the normal, that line, at a right angle to the surface before you can finally measure your angles. See how every step flows logically into the next? That's the secret sauce. That's what gets you the big mark. Okay, moving on. We've done the experiment, now it's time to deal with the data. Questions 1.3 and 1.4 are all about plotting a graph and, just as importantly, figuring out what that graph is actually telling us. So for 1.3, you get 2 marks, 1 for plotting the points correctly and 1 for drawing the line of best fit. And listen up, because that phrase, line of best fit, is a classic exam trap. So many people automatically think it has to be a straight line drawn with a ruler, but it doesn't. The best fit is whatever line or curve follows the pattern of your data. That is a massive takeaway. This leads us perfectly into question 1.4. You have to use the graph you've just drawn to explain why the angle of refraction is not directly proportional to the angle of incidence. So what is it about the shape of that line that tells you that? And you know what? The mark scheme is looking for a really simple answer here. All you have to say is that the line is a curve, or that it isn't straight. That's it. But why?
Well, in physics, the term directly proportional has a very specific meaning when you look at a graph. It means it's a straight line that goes through the origin, through 0, 0. Our graph is a curve, so the relationship can't be directly proportional. Easy mark if you know the definition.
Right, we're on the home stretch of question 1 now. We're shifting gears a bit, away from the practical method and data and into some core knowledge about how light actually behaves, specifically reflection and refraction. Question 1.5 gives you this diagram of a light ray hitting a reflector inside a car headlight. Your job is to complete the diagram by drawing where the reflected ray goes. Now notice it's a 2-mark question. That's a huge clue that there are 2 distinct things you need to do to get it right. So, how do you lock in both of those marks? This is key. The first mark you can get before you even draw the reflected ray. You get 1 mark just for drawing the normal, that dotted line at 90 degrees to the surface. Always draw the normal first. The second mark is for then applying the law of reflection and making sure the angle of incidence equals the angle of reflection, so I equals R. But if you don't draw the normal, you can't get that second mark.
And for our last point, question 1.6 is a multiple choice question. It's testing if you understand refraction. That's the bending of light when it goes from one material, like air, into another, like this transparent cover.
The mark scheme confirms that the first diagram is the right one, but let's quickly break down why. When light enters a denser material, like glass or plastic, it slows down. And when it slows down, it bends towards the normal. Then, when it leaves the other side and goes back into the air, it speeds up again and bends away from the normal. The first diagram is the only one that shows that towards, then away pattern correctly. That's the physics you need for the mark.
And there we have it. We have dissected all 13 marks available for question 1. So let's just pull it all together and think about the key lessons we can take away from this, looking at it like an examiner would.
So, what are the golden rules we've just learned? First, details matter. That single mark for the protractor resolution proves you have to read your equipment carefully. Second, for those big 6 markers, structure is everything. It's not just about what you know, but how logically you can explain it. Third, don't make assumptions. A line of best fit can absolutely be a curve. Fourth, definitions are easy marks, so know them. Directly proportional was a quick win. And finally, my pro tip for any diagram with light rays, always draw the normal first. It's often a mark all by itself. And that wraps up our breakdown. Seeing the question and the mark scheme right next to each other really takes the mystery out of it, doesn't it? So the final thought I'll leave you with is this. Now that you know exactly how these questions are marked, how are you going to change your approach the next time you see one? Thanks for watching.